Okay. In this video, we will discuss about the uh, hypothesis space. What is a hypothesis space? We have seen the hypothesis, right? In the previous video, we have seen the hypothesis. So it is the rule to get the target function. So the hypothesis space is nothing but it is a set of all possible solution, all possible rules that a machine learning model can consider while trying to learn the pattern in the data. The hypothesis space is nothing but a set of rules or set of all possible solutions that the machine learning model can consider while trying to learn the pattern in the data. It contains all the possible hypotheses that could explain the target function. If I say target function f of x, so it is having all the possible hypotheses that could explain the target function. And the best model or the best hypothesis from this space that fit for the given data makes the accurate prediction. So we are considering the best hypothesis from this hypothesis space. So if I say that the regression says the hypothesis space as a set of linear functions. If I consider regression function, it is having a linear functions, and if I consider the decision tree model, it is having a hypothesis space of tree structure. So if I say it is having a tree structure, right? So there is a difference between one model to the another model. So regression model is having the linear functions, and decision tree, if I consider, it is a tree structure. So the subset of the hypothesis space that correctly fit all the given example, that one we will call it as version space. So version space is a subset where the hypothesis subset of the hypothesis space. Version space is the subset of the hypothesis space that correctly fit all given training examples. All given, all it will correctly fit for all given training example that contains a hypothesis that are consistent with respect to observed data. So whatever the observed data which will be coming, so it is having a consistency with the all the hypotheses which are consistent. The hypotheses which are placed in version space are having a consistent with respect to all observed data. For example, if I say that rule for classifying the animals, elephant or not elephant, hypothesis space includes all the rules. That is, has tusk, has four legs, has is a grey. All these, whether it is no or yes, it is consisting all the rules, right? Hypothesis space. The model, machine learning model, select the best rules, best hypothesis. We will call it best rules or best hypothesis that matches most examples correctly. That matches most examples correctly, right? And next one, the version space. Version space contains only the hypotheses which are correct. That is, which are properly classifying the training data, which are correct according to the given training data. That we will call it as version space. Concept of best pattern, that is nothing but there is a difference between the hypothesis space, machine learning model, and version space. So I have explained. So hypotheses include all the rules. Machine learning models, which will be rules or hypothesis that matches the most of the examples. Version space, which has the best one, which is having consistent with all the instances, all the examples. The hypothesis which is having consistent with all the examples. So that we will call it as a version space. Okay, so that is what about the uh, hypothesis space. Now, for example, if I consider the previous example of this elephant, which is having horns, tails, tusk, paws, row, paws, color, have, size, hoof, size, and it's a classified dependent attribute. It is a elephant. So consider, so these which are stated over, you can see over here, horns are having two possibilities, no and yes, right? Tails again short or long. Tusk is again yes or no. Paws is no or yes. Fur is again no or yes. Color again black and brown. And hooves, that is no or yes. Size medium or big, two possibilities. Elephant no or yes, right? So if I consider for each example, we have all the two possibilities over here. And color, I think we have three colors, huh? Yeah, black, white, and brown. Okay. So we have a possibility of three colors, and who is two, and size is medium and big. So there is all the features except one, which are having two possibilities, and one is having three possibilities, right? So total that which we can say, so total instance calculation, that is if I go over the all the things, the whose, tails, plus, so if I consider two possibilities, total instances, that is considering the value of each attribute, they are total instances calculation. If I do it, that is multiplying the number of possible values for each attribute, that is 2 into 2 into 2 into 2 into 2 into 3 into 2 into 2. So total is 384 possible animals can exist, right? If I do 1 combination, if I easily say 384 distinct instance covering. Distinct instance means 284 possible animals I can classify. 284 way elephant I can classify, right? Elephant or not elephant I can classify, or the possible animals can I can classify, and exist based on the combination of these attributes. And if I want to write the hypothesis for this, total hypothesis if I find out, so number of instance plus additional two values we know, right? What are the two values? One is any value, one is no value, that is question mark and phi, right? When learning the concept of hypothesis rules, we have the attributes, that is specific instances. Attributes, what we will say, horns, tails, tusk, paws, fur, color, hooves, and size we have seen, right? Yes or no, long or short, yes or no, yes or no, yes or no. In that way, if I define it specifically, for horns yes and horns no, tails long or tails short, or tusk yes or tusk no, if I do it specifically, I will get 384, that is a 2. For each attribute I will get 2. Along with that, each attribute I will get again another 2, that is any value, that is question mark, and one more is psi value. I have stated over here, we can generate another 2 more values, question mark and xi value, right? So question mark as I value. If I consider that also, then 2 plus 2, 4. Again 2 plus 2, 4. Again 2 plus 2, 4. 2 plus 2, 4. 2 plus 2, 4. And 3 plus 2, 5. 4, 2 plus 2, 4. 2 plus 2, 4. If I do it multiplication, I will get 81,920. So these hypotheses represent different way of model can classify. These hypotheses represent different way of classify the animal. So these much possibilities I can do. These much hypothesis I can write for the given 8 attributes. Okay, and there are many possible of instance. There are many possible instance, that is 384. Even more possible of hypothesis. So all these hypotheses where I can define hypothesis space. Okay, so that is what the importance of the distinguish between the hypothesis and hypothesis space are the instance and hypothesis, the possible instance and possible hypothesis what we can write for each and every problem, so that you have to know how to write all those things. Okay, and next, heuristic space search. Heuristic space search is a such strategy that iteratively find the optimized hypothesis or solution for improving its heuristic function. Sorry, for based on its heuristic function or the cost measures. That is, each and every hypothesis we are finding the cost, and based on that we are identifying which is a optimized hypothesis. Such strategy that iteratively find an optimized hypothesis or the solution by improving the based on the heuristic function or the cost measures. Like we have here, we have here, uh, and there are several heuristic functions which we can use it. We know that there are like hill climbing methods or the search best search or width first best first or A star algorithms. That's what we have seen in the artificial intelligence. So introduction to artificial intelligence in the first semester, I think you came to know about all these things. So I won't explain all those things. But heuristic methods, these are some of the heuristic methods. From that we can find the optimized hypothesis. In this we can segregate this search methods with the different ways. One is generalization and one is specialization. So generalization is nothing but general to specific. Generalization is specialization. Uh, Hypothesis space can search it with the approximate hypothesis that matches all the possible instances, but not matches with the negative instance. That is generalization to specialization. Generalization and specialization means positive instance it should be match. Uh, the main importance of generalization and specialization is hypothesis case can be searched for approximate hypothesis that matches with all positive instance. Means when we are segregating this generalization and specialization, the whatever the hypothesis which we are defined or whatever the hypothesis we are derived that matches with all positive instances but does not matches with the negative instance. So that is what the main aim when we are specifying the generalization or specialization. We have two methods as I told, specialization and generalization. Specialization is general to specific learning. Generalization is specific to general learning. Sorry, generalization is which I have confused or yeah, wait, I will explain once again. The specialization is general to specific learning. Generalization is specific to general learning. It's entirely different. So generalization start with the most general hypothesis and defining it by adding the constraints of the positive instances. Okay. Positive instances means it is an elephant. If I consider example of a previous one, it is an elephant. Yes, elephant. It is classified as elephant. Generalization is begins with that is specific to general, right? So begins with most specific hypothesis and progressively generalizes its cover more instances. So we will see with the examples generalization and specializations. Generalization. First one is generalization. Learning methodology searches. What is generalization? As I told, it is a generalization is nothing but begins with the most specific hypothesis specific to general, right? More specific hypothesis and progressively generalizing its cover more instances. This learning methodology is searches the specific, hypothesis space by starting with the most specific hypothesis. What is the most specific hypothesis? How we will represent the most specific hypothesis? We will see in the next slide. We have that. Okay. And goal to find approximate hypothesis that cover all the positive instances. Goal to cover approximate hypothesis that cover all the positive instances. So as I told, if it is most specific, we are initializing with the most specific hypothesis. What is the representation? That is phi, right? So H is defined with the phi because we have 8 attributes in our elephant problem. So that is I have defined initialized with the 8 phi hypotheses. 5, 5, 5, 5, 5, 5, 5. So that is a specific hypothesis. Now, first one. So if I consider the example of first one, okay. Before that, I will explain the concept. Explain the concepts of generalization over here. So once we define the specific hypothesis over here, 5, 5, 5, 5. Now, whatever the positive instances will be coming, we are defining with that positive instance specific terms. Okay. And if it is negative which is matches with that, then we were replacing it. We will see that. And if it is alternative positive coming, then we will generalize it. We won't replace with negative. If it is coming alternative positive, that is anything opposite to this attribute, which is also stated with the positive instance, then we are generalizing them. We will see that. First, we are initializing with the 5, 5, 5, 5, right? All the attributes of the initialized instance, we are defined with the 5. Now, iteration 1, I am stating the hypothesis which is related to this. No short, yes, no black, no big, right? So, which I am initializing over here, iteration 1. Iteration 1, which I am initializing with the positive instance, no short, yes, no black, no big. That is a positive instance because it is classified elephant is yes. So that is a positive instance. So I am stating over here. Now my first hypothesis, the specific hypothesis of phi, now replace it with the no short, yes, no black, no big. Okay. Next, the next iteration, the next one, which is iteration 2, which is having negative instance. This is a positive instance, that is elephant S classification. This is a negative instance. What is the negative instance attributes? It is yes short, no, brown, yes black, right? So this one I have stating over here. Iteration 2, I am stating given stated the second instances, that is negative instance, are yes short, no, brown, yes medium. That is no. That is no means negative instance. It will not classify the elephant. So what I will do, I am ignoring this because it is not classifying elephant, right? So why should I have to consider the attribute of this to alter my hypothesis or generalize my hypothesis? So I am not at all considering this instance. So what I will do, I will keep it as remain, which is I have stated with the first one. Okay. So in the next iteration, again it is a no short, yes, no black, no medium, yes. So this is a positive instance because it is classifying the elephant. So that is positive instance. No short, yes, no black, no medium. That is yes, positive elephant, positive instance, and it is classifying the elephant. Now I am applying my previous hypothesis and comparing with the iterations. no no right, yes yes, short short right, yes yes right, no no right, no no right, black black no right, no no right. Now medium and big also elephant, medium also elephant. So now I have two attributes, different attributes, which will classify same positive instances. So now it is a time to, I have to generalize this and this, that is big and medium, right? So big and medium I will generalize it, I will make it as a question mark over here, I will mark it as a question mark over here. So that is a question mark I will place instead of big, I will make it as question mark. Question mark means it is a general hypothesis where sorry, general term which will consider both any value, that is medium or big. So generalization, I have made it as generalized, specific to general. Now next one, fourth one is again negative instance, it is not classifying the elephant, it is no classify, won't classify animal elephant. The next is fifth one is what, no short yes yes yes, black no big yes. It is again positive instance, it is classifying the elephant, that is no short yes yes yes, black no big yes, positive instance. So it is classifying again elephant. Now I will compare with the previous hypothesis and this iteration, that is no 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 is a specific instance, and short 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 again, yes yes yes. And again here, when it is comes to the attributes of this is what related to fourth, right? Fourth one, pause, previously it is no, here it is yes, and for also previously it is no, here it is yes, right? So yes yes, yes and no over here, when it is comparing both are positive instance. Now I have to generalize these two again, this one and this one and this one. So no yes, I will make it as question mark, it is generalized now, whether it will take both value yes or no, and it is again yes or no, it will take both value. And black is black, it is a specific, and no is no, again no, and question mark and big, so it is again question mark. So this is my final hypothesis, generalized hypothesis, where it will consider positive instance, where it will matches with all the positive instance. Now it will be subsequently classify the positive instance, it is a true. So whatever the value over here, question marks and this question mark, the remaining value is no short yes, black and no. So whatever the value which will be taken by the question mark, it will classify as a positive instance, that is a elephant, it is an elephant. So that is what the generalization. Specialization is nothing but general to specific learning, general to specific learning, where the hypothesis is initialized with the general, most general way, and we are optimizing the hypothesis with the specifically for the uh, most positive instances, for the most positive instances. Like it is like, so learning methodology which is search through the hypothesis space, where the approximate hypothesis by specializing the most general hypothesis, specializing the most general hypothesis. So general to specific learning, the data instance is shown. We will see that. The previous example only I have considered this one, but I have initialized with the question marks. Previously I have initialized with the pies, yeah, pies, and now which I have initialized with the question marks, right? This question mark, now you can comparing with your iteration 1, that is positive instance. No short yes, no no, black no, big, right? Yes, positive instance, right? So here question marks are there. So question mark means it will take any value, so I won't replace question mark with the this. So hypothesis 1 I have defined with the question mark. So question mark means it is a generalized, means it will take any value, whether it is no or yes, short or big, yes or no, yes or no, yes or no, black, blue, no, white, whatever it may be. So it will take any value over this, right? So what I will do, I will make I have defined the question mark, right? So I won't replace, I want to change the question mark. So I will keep it as question mark as it is, positive instances. Now, when it is comes to the iteration 2, it is a negative instance, right? It is a negative instance. It is a negative instance where it is stated with the yes short, no, 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 brown, yes, medium, right? So it is a negative instance. The values which are the attributes are this way. And now my hypothesis, initially I have defined with the all question mark, right? So now my hypothesis would be either this is no, because this is negative instance. So if I put a question mark yes here also, then it is ready to take negative instance also. But my hypothesis, I have to define it for only positive instances, not for the negative instances. So what I will do, I will make it as no, and all other are in the general form. First one I can define with the in this way, first hypothesis of H2, or I can define with the in this way, that is first one is question mark and any one attribute which is defined as yes. Okay, either in this way or either in this way, that is not brown color, it should be a black. Not no, it is yes, and here it is not yes. If I go for horns, horns should be no. If it is yes written, then it is no, so it should be a no. I have to define with no. So in that color also it should be a black, not a brown. And again it is a medium. If I define it, the question mark should be a big, not a medium. It should be a big. Elephant should be a big. Okay. So in this way, I have to define different hypotheses with the negative to these negative instances. Opposite to negative instance. Negative to negative instance means opposite to negative instance. Means one hypothesis is in this way, or in this way, or in this way, or in this way, or in this way. So these are the possible hypothesis for when I consider the negative iteration 2, that is negative instances. Now we will consider this is my second hypothesis. Considering all the 5 hypotheses, I will consider as a second hypothesis. Now impose the constraints that will not classify the negative instance. So these are constraints which I have mentioned. So it will now it will won't classify the negative instance because all are different from this, right? So from general to I have made it a somewhat specific, right? Now we will consider the third iteration. Third iteration is nothing but again it is a positive instance. No short, yes, no, no, black, no, medium, right? So these are the attributes of the negative positive instance. Now whether it is matching with the hypothesis 3, because it should match, right? It should match because we have written the hypothesis for positive instance, not for the negative instance. So it should match. So no, no is matching, yes, yes is matching. So here again there is question mark. Question mark will accept any value, and black, black is matching. No, no is matching, and big, medium. So big, medium, which is not matching. So what I will do? What I can do? I can make it as a question mark, right? I can make it over here question mark, or I can skip that. So if make it as question mark, then it will accept this also, medium also. So medium, if it is accepted, then it will follow the negative instance, right? So for time being we will skip that. So I will make it as a specific one, big only I will consider. Big means only, then it is for classify the negative instance. Okay. So it should be a big, then only. So this hypothesis will not match with over here. Okay. So you can skip this. So I have not skipped. So you can skip that. So you won't write. So now we will skipping that part. We will see the later. So now these are my possible hypotheses. Won't refer the last one. Won't refer the last one because I am skipping this. I won't consider this because it is won't matches with this. Okay. So I have forgotten to remove this, so leave it. So this one you cannot, this one you cannot consider, so this is gone, so we cannot use that. So another 4 is considered, right? Another 4 is considered, another 4 is considered, so these 4 we will consider now. So these 4 we are considering now, and this 4, what we will do in that 4, we will consider the next one, negative instance. Negative instance we are matching with our previous one, that is this 4. Again, here it is 4 instances where no, all question mark, yes, all question mark, all question mark black, all question mark no, right? So we will consider that, and whatever matches with that, whatever matches with over here, so that one I have to neglect it. Means remove any hypothesis which is inconsistent with the negative one. So here it is, I have considered this is, I should not consider this, because if I consider this then it is wrong, because it is wrongly mentioned in your textbook. So we should not consider this. Okay, and these are question mark. So here it is no. We can consider over here yes and over here. So other two which are gone out of 4, only 2 I have written over here. So which one is gone? First one, no. Here it is again. Here it is again no is there. So no is for the positive instance which I have written, but that no is matching with the negative instance. So what I have to do, I have to make generalized, means I have to remove this when I am considering for the next one. So I have removed that. Again, the next one is this is again yes and no, so it is opposite to this instance, so I can keep that. And color, again the color is matching black, positive instance. Here it is white, negative instance, it is opposite to that, so it is matching. And next one is nothing but no. That is what no, which what is that no? Whose, whose, which is no, it is written over there. Whose, which is written as no over here, and that is matching with the our negative instance. No, here it is no, whose. So I cannot consider that. So what I will do, I will remove this instance also. So now remaining is 2 instances, 2 positive hypotheses for the given negative instance. So these 2 are now generalized. And again, this hypothesis I am comparing with the next iteration, that is I5. That is iteration 5 with the positive. Last one is positive instance, right? So last one is positive instance. It is classifying as a elephant yes. So I am taking that no short yes, yes, black no, big yes. So positive instance. Now I am comparing. This is not there. Sorry, this is not there. So I am comparing this with the these positive instances. So that is question mark, yes, no. Yeah, it will be answerable, means it is taking any values. Short it will considering yes, yes, yeah, matching. And question mark also it is take any values, and yes, yes, it is matching. Yes, yes, matching. Yes, question mark is taking any values. Black is matching. No, no, it is again question mark is taking any value. Big question mark taking any value. So these two are specific instances, specific hypotheses which can leads with the positive instance. Now in the generalization we got two, uh, in the specialization we got two hypotheses, but in the previous generalization we got to one hypothesis at the end, right? So here we have two hypotheses. One is this, sorry, one is this and one is this. So both will leads with the positive instance. Both will leads with the positive instance. So it will be classifies the results. Okay, we have the related to this. We have one find yes algorithm. So that we have in the lab. We will discuss over there. Okay. So that about the that is about this recording. The next recording, which I will explain about the measurement performance measurements. Okay.